All right, let's dive into a topic that's, believe it or not, the absolute backbone of the industrial world: serial communication. We're going to break down the essentials you absolutely need to know to work smarter and faster out in the field.
So I know exactly what some of you are thinking. Serial communication? Isn't that ancient technology? And yeah, you're not wrong. It's been around for a long time. But here's the reality. The overwhelming majority of industrial systems running right now still rely on standards like RS232 and RS485 to keep the machines talking and the production lines rolling.
So why is it stuck around for so long? Well, it all comes down to a few key things that make it perfect for the factory floor. First, it needs very little hardware. It's also fantastic over long distances, and it's a real champ at handling all the electrical noise you find in industrial plants. But the big one? It's just simple and incredibly reliable. It just works.
Now that we get why it's still king, let's look at the two main ways serial devices are physically wired up. Honestly, understanding this is the very first step to figuring out any network issue.
On one hand, you have point-to-point, which you'll usually see with RS232. Think of this like a private, one-on-one conversation. One device talking to one other device, and that's it. A classic example is you plug in your laptop directly into a PLC. Then, on the other hand, you've got multi-drop, which is RS485's territory. This is more like a conference call. You have one master device, like a PLC, that can talk to a whole bunch of slave devices, maybe a row of motor drives, all sharing the same pair of wires.
And that leads to a super handy rule of thumb for when you're out in the field. If you walk up to a control panel and you see a whole chain of devices daisy-chained together on the same two wires, you can bet you're looking at an RS485 network. It's pretty much a dead giveaway.
Okay, so knowing the hardware, the physical connection, that's really only half the story. We also have to understand the language they're speaking over those wires. And that brings us to the most common dynamic duo in the entire industrial world.
Look, if you're working in a factory, a water treatment plant, any industrial setting, RS485 is the one you're going to see over and over again. It's that robust, long-distance, multi-device standard that has really become the workhorse for everything we do.
And the protocol, the set of rules for the conversation that usually runs on RS485 is Modbus RTU. The concept here is just beautifully simple. It's a master-slave system. The master is the boss. It's the only one that can start a conversation. And the slaves, they're the workers. They stay completely silent until the master asks them a direct question.
Let me paint you a picture of how that works. The PLC, our master, sends a very specific request out on the network, addressed to one particular temperature sensor, our slave. It asks, hey, what's your current temperature? Then, and only then, does that sensor reply with the data. It's a simple call and response, and the key thing to remember is, if the master doesn't ask, the slave says absolutely nothing. Now, for this whole conversation to actually happen, for any of this to work, every single device on that network has to agree on a few non-negotiable rules. These are the critical communication settings. I like to call these the big three. First, you've got the baud rate. Just think of that as the speed of the conversation, how fast they're talking. Then there's parity, which is a really simple form of error checking to make sure the message didn't get scrambled along the way. And finally, you have stop bits, which basically tell the listening device, okay, that's the end of this piece of data.
And here is the most crucial point I can make. Every single one of these settings has to match exactly on every device. No exceptions. Look at this example. The parity matches, right? But the baud rates are different. Because of that one little mismatch, the PLC and the drive can't understand a single word the other is saying. Communication completely fails. It's all or nothing.
So, what happens when your settings are perfect? You've checked them, you've double-checked them, but the network is still flaky, Maybe it works for a few minutes and then drops out, or you're getting garbage data. What's going on there?
Well, I'll tell you, 9 times out of 10, the culprit is a tiny and very often forgotten little component, the termination resistor. This is hands down one of the most common problems you'll find with RS485 networks in the real world.
So what is this thing? A termination resistor is just a small resistor that you place at the very beginning of the wiring chain and at the very end. Its job is critical. It acts like a shock absorber for the electrical signal, preventing it from hitting the end of the wire and bouncing back, which would corrupt the data for everybody else on the network.
Okay, let's put all of this together. I want to give you a professional 5-step checklist you can use every single time you're standing in front of a system that's just not talking. This is your field toolkit. Step 1. Always start with the physical stuff. Check the wiring. Are your A and B terminals swapped? Is there a loose connection somewhere? Step 2. Check the settings. Go device by device and verify our big three, baud rate, parity, stop bits, are identical. Step 3. Verify the addresses. In Modbus, every slave needs its own unique address. Do you have any duplicates? Step 4. Check for termination. Are those resistors physically there at both ends of the network? And finally, Step 5. Make sure the master is even trying to talk. Is it actually polling or sending requests? Remember, if it's not asking, you're not getting a response.
And here's why that simple checklist is so incredibly powerful. An estimated 80%, yeah, 80, of all serial communication problems are not some deep complex issue in the PLC's programming. They're simple wiring mistakes or mismatched settings. The fundamentals are what matter the most.
So look, while serial communication might seem like simple, old-school tech, mastering its principles is one of the most valuable skills you can possibly have in the automation world. If you can confidently walk up to a dead network and bring it back to life, you will troubleshoot faster, you'll work so much smarter, and you will absolutely stand out as a top-tier engineer or technician.